In this lesson, we will read a wave from a y versus x graph and write its mathematical description. At time t equals 0, we know three measurements: x naught equals 2.0 meters, y naught equals 1.4 meters, and y max equals 2.0 meters. The period is 2.0 seconds, and the wave moves to the right. We will find y of x comma t in the standard traveling wave form. Let's first set up a clear xy axis and place the given information on the diagram. At time 0, the amplitude is 2 meters. I will draw dashed horizontal lines at +2 and -2 to highlight the amplitude range, labeled y max. Now, I mark the given point at x equals 2 meters with y equals 1.4 meters. This dot should sit on the wave's initial shape at time 0. From the graph, we read a wavelength of 8 meters. So I will mark lambda equals 8 meters along the x-axis. Now, let us extract the parameters for a right-moving sinusoidal wave. The standard form we will use is y of x comma t equals a times cosine of kx minus omega t plus phi. First, the amplitude a equals y max, which is 2.0 meters. The period is 2.0 seconds, so omega equals 2 pi over t, which is pi radians per second. The wavelength is 8 meters, so k equals 2 pi over lambda, which is pi over 4 radians per meter. Next, we determine the phase angle phi using the condition at time 0. At t equals 0, the wave is y of x comma 0 equals a cosine of kx plus phi. Plug in x equals 2 meters and y equals 1.4 meters. We have 1.4 equals 2 times cosine of left parenthesis pi over 4 times 2 right parenthesis plus phi, which is 2 times cosine of pi over 2 plus phi. Using the identity cosine of pi over 2 plus phi equals negative sine of phi, we get 0.7 equals negative sine of phi, so sine of phi equals negative 0.7. The principal value for phi is about negative 0.78 radians. We will round the phase to 2 significant figures as requested. Now we can graph the initial shape y of x comma 0 with amplitude 2, wave number pi over 4, and phase negative 0.78. The orange dot at 2, 1.4 should sit on this curve. We now write the full traveling wave moving to the right. The mathematical description is y of x comma t equals 2.0 times cosine of left parenthesis pi over 4 times x minus pi times t minus 0.78 right parenthesis, with y in meters, x in meters, and t in seconds. To build intuition, let us watch the wave travel to the right as time increases. The green curve shows y of x comma t in motion for about 2 seconds. Notice how the pattern shifts toward positive x while the amplitude and wavelength stay the same. Summary: amplitude 2 meters, wavelength 8 meters, period 2 seconds, and phase about negative 0.78 radians. The right moving wave is y of x comma t equals 2.0 times cosine of left parenthesis pi over 4x minus pi t minus 0.78 right parenthesis.